Alright, so in this problem, I have phi to the power of x plus phi to the power of x is equal to 7. So to start, I'm going to factor out phi to the power of x from my left-hand side. So now I have phi to the power of x times 1 plus 1 is equal to 7. Now 1 plus 1, that's equal to 2, so I have phi to the power of x times 2 is equal to 7. Now I'm going to divide both sides by 2, so then these two cancel out, and I get 5 to the power of x is equal to 7 over 2. Now from here, I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So now I have x times log 5 is equal to log 7 over 2. Now I'm going to divide both sides by log 5. These two cancel out, and I get x is equal to log 7 over 2 over log 5. Now if I have something in the form log a over b, this is equal to log a minus log of b. So in this case, I have log 7 over 2, and I can rewrite that as log 7 minus log 2, and I have this over log 5. So now that this is all simplified, all we need to do is plug in the values of log 7, log 2, and log 5. So log 7 is equal to 0.8451. Log 2 is equal to 0.3010. And log 5 is equal to 0.6990. So I have x is equal to 0.8451 minus 0.3010. And I have this over 0.6990. So if we simplify all of this, we get that x is equal to 0.7784. Alright, so in this problem, I have x to the power of 4 is equal to 1. So I'm going to first start by subtracting 1 on both sides. So then these two cancel out, and I get x to the power of 4 minus 1 is equal to 0. Now x to the power of 4, I can rewrite this as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can write this as x to the power of 2 to the power of 2. Now I have this minus 1 is equal to 0. Now 1 is the same thing as 1 squared. So I have x squared to the power of 2 minus 1 squared is equal to 0. If I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 1. So I have x squared plus 1 times x squared minus 1, and this is equal to 0. Now, remember how now this is equal to this actually gives me two equations. I have x squared plus 1 is equal to 0, and I have x squared minus 1 is equal to 0. So for x squared plus 1 equals 0, I'm going to start by subtracting 1 on both sides. So these two cancel out, and I get x squared is equal to negative 1. Now if I take the square root on both sides, the square root of x squared is x, and the square root of negative 1, if you guys already know, is I. So I have positive negative I. And for x squared minus 1 equals 0, I'm going to add 1 on both sides. So I get x squared is equal to 1. If I take the square root, I get x is equal to positive or negative 1. So that's 2 more solutions. So these are my 4 solutions to this problem. Alright, so in this problem, I have x to the power of x to the power of 10 is equal to 400. So to start, I'm going to rewrite 400. Actually, before that, I'm going to rewrite 400 as 20 squared. And now I'm going to take the power of 10 on both sides. So now I have x to the power of x to the power of 10 to the power of 10 is equal to 20 to the power of 2 to the power of 10. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So in this case, we can think of x to the power of 10 as m and 10 as n, and I can switch these two places. So now I have x to the power of 10 to the power of x to the power of 10. And also, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this is the same thing as 20 to the power of 2 times 10, which is 20. Now I'm going to let x to the power of 10 equal to the variable y. So now I have y to the power of y is equal to 20 to the power of 20. And a to the power of a equals b to the power of b. This means that a equals b. So y is equal to 20. Now remember how we let x to the power of 10 equal to y, meaning x to the power of 10 is equal to 20, and x is equal to the 10th root of 20. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2, and I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4,000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4,096 squared is really hard to calculate by itself. So if we change it to 4,000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4,000 and b is 96. So this turns into 4,000 squared plus 2 times 4,000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now, 4,000 squared is equal to 16 million. 2 times 4,000 is 8,000, and 8,000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem.